Welcome back, my dear students. In this session, let us learn part 3 of chapter number 5, data handling. Chance and probability. There are certain experiments whose outcomes have an equal chance of occurring. A random experiment is one whose outcome cannot be predicted exactly in advance. Outcomes of an experiment are equally likely if each has the same chance of occurring. So, probability of an event is equal to number of outcomes that makes an event divided by total number of outcomes of the experiment when the outcomes are equally likely. One or more outcomes of an experiment make an event. Chance and probability are related to real life. So this is a formula we have to use. If we want to find out probability of an event, number of outcomes that make an event divided by total number of outcomes of the experiment when the outcomes are equally likely. Now let's try questions. Exercise 5.3, question number 1. List the outcomes you can see in this experiment. A. Spinning a wheel. B. Tossing two coins together. Here the question is asking that if we are spinning this wheel, then here is one arrow mark. So if we are spinning this wheel, then we are going to write, or we are going to give list the outcomes. Then means if this arrow mark is pointing to A, then the outcome is A, and if this arrow mark is pointing to B, then the outcome is B, and if the arrow mark point to C, then the outcome is C. If the arrow mark point to D, then the outcome is D, and so on. So for this outcomes of the spinning a wheel is A, B, C, and D. So answer A, outcomes you can see in spinning a wheel are A, B, C, and D, and these are the outcomes. Now for B, tossing two coins together. So here is two coins. If these two coins are tossing together like this, then we have to list the outcome. If the two coins are showing these two heads, then the outcomes are head. And if one coin show head and the second coin show tail, then this is head and tail. If both are showing tail, then the outcome is tail. And if the first coin show tail, this is tail, and if the outcome of the second coin is head, then this is head and tail. Tail and head. This is tail and this is head. Tail and head. So possible outcomes are head, tail, tail, and tail, head. Now question number 2. When a die is thrown, list outcomes of an event of getting Roman number 1, A prime number, B, not a prime number. Roman number 2, A number greater than 5, B, a number not greater than 5. This is a dice. In a dice there are 6 numbers. This is 1, this is 3, and this is 5. But in a dice there are 6 numbers: 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. So in Roman number 1, we have to list the outcome of an event getting a prime number. So in this one, 1, 2, 3, 4, 5, 6, the prime numbers are 2, 3, and 5. So there are 3 prime numbers are there, 2, 3, and 5. So for this Roman number 1A, the outcomes of getting a prime numbers are 2, 3, 5. That means a prime numbers 2, 3, 5. Next is B, not a prime number, and here in this 1, 2, 3, 4, 5, 6, the numbers which are not prime are 1, 4, and 6. So the outcomes are 1, 4, 6. So not a prime numbers are 1, 4, 6. Now Roman number 2, a number greater than 6. From this 1, 2, 3, 4, 5, 6, a number that is greater than 5 is 6. So the outcome is 6. Not a Roman number 2, a number greater than 5 is, that is 6. B, a number not greater than 5 are 1, 2, 3, 4, and 5. And these are the outcome here. Question number 2 is over. Now question number 3. Find the Roman 1 probability of the pointer stopping on D in question number 1 to A. B, probability of getting an S from a well shuffled deck of 52 cards, playing cards. C, probability of getting a red apple. C, figure 5.20. In this figure, we have to find out the probability of getting a red apple. Now let's try to solve this Roman 1. Probability of the pointer stopping on D in question number 1A. This is the diagram of question number 1A. Here is one pointer, and we are going to find the probability of this pointer stopping at D. So in this A, B, C, D, D, there is only one D. So now here is the solution. Number of possible outcome for pointer stopping on D is only 1. Since here is only one D. Total number of outcome of the experiment are 5. 1, 2, 3, 4, 5. So there are 5 outcomes are there. 1, 2, 3, 4, 5. So total number of outcome of the experiment is 5. Therefore, probability of the pointer stopping on D, there is 1 divided by 5. So 1 by 5 is the answer. Now next is question number B. Probability of getting an S from a well shuffled deck of 52 cards. In a deck of 52 cards, there are 4 S's are there. So here B, number of possible outcomes. Since in a deck of 52 cards, altogether there are 52 cards. So the number of possible outcomes is 52. Number of an S in a pack of 52 cards is 4. Therefore, probability of getting an S is 4 divided by this 52. 4 can divide 52, then we are getting 13. That means 1 by 13 is getting. Now question number C. Probability of getting a red apple. C, figure 5.20. In this figure, we have to find out the probability of getting a red apple. So here altogether 1, 2, 3, 4, 5, 6, 7 apples are there, and how many reds are there? Red, 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 red. There are 4 reds are there. 1, 2, 3, 4. There are 4 reds, and total number of apple is 7. So number C. Total number of apple is 7. Number of red apples is 4. Therefore, probability of getting a red apple is 4 divided by 7. That is 4 by 7. And this is the probability of getting a red apple. Question number 4. Numbers 1 to 10 are written on 10 separate slips. One number on one slip, keep in a box and mix well. One slip is chosen from the box without looking into it. what is the probability of Roman number 1 getting a number 6, getting a number less than 6, getting a number greater than 6, Roman number 4 getting a one digit number. Okay, now let's try to answer this. Now solution. Since there are 10 slip and any slip can be taken out, so total number of outcome is 10. Now Roman number 1 getting a number 6. You can get a slip written 6 only once, so favorable outcome is 1. Therefore probability of getting the number 6, so in that number 1 2 3 4 5 7 8 9 10 there is only 1 6 and there are 10 numbers are there. 10 numbers are there. That means probability of getting the number 6 is 1 by 10. Now Roman number 2, this getting a number less than 6. The number less than 6 are 5 4 3 2 1. So there are 5 different numbers are there less than 6. So we have 5 numbers less than 6. That is 1 2 3 4 and 5. Therefore favorable outcome is 5, these 5 numbers. Hence P means for probability getting a number less than 6 is equal to 5 favorable outcome, and there are 10 numbers. If 5 and 10 are dividing by 5, then we are getting 1 by 2, and 1 by 2 is the required probability. Now Roman number 3, getting a number greater than 6. A number greater than 6 are here in this case 7 8 9 and 10. So Roman number 3, the number greater than 6 are 7 8 9 and 10. So there are 1 2 3 4 favorable outcomes are there. So favorable outcomes are 4, 1 2 3 4. Therefore probability of getting a number greater than 6 is so favorable outcome is 4 and total number outcome is 10. That means 4 by 10. If 4 and 10, if we divide by 2, then we are getting 2 2 are 4, 2 5 times 10. That means 2 by 5 is getting. Now Roman number 4, getting one digit number. Here in this case all the numbers are one digit except 10. So there are 9 one digit numbers, that is 1 2 3 4 5 6 7 8 and 9. So favorable outcomes are 9. Since there are 9 numbers are there, therefore probability of getting one digit number is 9 by 10. So these are the answer. Question number 5. If you have a spinning wheel with a 3 green sector, 1 blue sector and 1 red sector, what is the probability of getting a green sector? What is the probability of getting a non-blue sector? Now solution. There are 5 sectors in all, 3 green, 1 blue, 1 red. Hence total possible outcome is 5. Since we have 3 green sector, there is number of favorable outcome is 3. Therefore probability of getting a green sector is 3 by 5. Also there are 4 non-blue sectors. Favorable outcome is 4. Thus probability of getting a non-blue sector is 4 by 5, and these are the answer. Now next question number 6. Find the probability of the event given in question number 2. This is question number 2. In this case we have to find out the probability of getting a prime number, B, probability of getting not a prime number, and Roman number 2a, probability of getting a number greater than 5, and in B, probability of getting a number not greater than 5. Okay, now let's try to answer this. Solution. There are 6 outcomes in all, 1 2 3 4 5 6. In a die there are 6 numbers. They are 1 2 3 4 5 6, and these are the outcome. There are 6 outcomes in all, 1 2 3 4 5 6. Roman number 1a. Since there are 3 prime numbers, that is 2 3 and 5, therefore favorable outcome is 3. Thus probability of getting a prime number is 3 by 6. 3 by 6, if we divide by 3, then we are getting 1 by 2. Here a is over. Then B, question number B. Here, favorable outcomes, there is not a prime number, there is 3. Hence, probability of not a prime number, that is equal to 3 by 6. If 3 and 6, if we divide by 3, then we are getting 1 by 2, and 1 by 2 is the answer. Now, Roman number 2. A. Since a number greater than 5 is 6, so favorable outcome is 1. Hence, probability of a number greater than 5 is 1 by 6. Now, question number B. Since a number not greater than 5 are 1, 2, 3, 4, and 5. So, favorable outcome is 5. Hence, the probability of getting a number not greater than 5 is 5 by 6. And this is the answer. Now, exercise 5.3 is over. Okay, for today, let's stop here. Okay, all of you, thank you.